In this video, we will learn how to find the prime factorization in Python. Let's get started. First, we will go with the definition and then we will proceed for some practical examples in Python. So, prime factorization, that is known as prime factors in short form. It is the way to represent a number as the product of its prime numbers, meaning that let's say we have a number 40. So what we are doing here actually that we are breaking down the number 40 in the product of its prime numbers, and when we back multiplied them we get the original number. So to understand it clearly, let's take this example here. The example is taken from the Q math. Here we have number 40 and we proceed to find the prime factor of the number 40. At the end, we are left here with the remainder 1. And these are all the numbers that are the prime numbers and the prime factors of the number 40, as we can see here. So we know very well that when we multiplied them all together, then we get back the original number. So this is how we can find out the prime factors. Let's see here one more example. We have number 30 and we know 5 by 6 is 30. But the main problem is that 6 is not the prime number. So we further divide the 6 into 2 by 3 and finally we get the prime factorization of 30, that is 2 by 3 by 5. We have two methods to find the prime factors. First is division method and second is field method. So I will start with division method. Let's first define the function and pass the parameter. So the parameter n will take an integer as the input. Now declare a variable divisor and initiate it with value 2. So value 2 is the smallest prime number here to find the prime factors. Now define a variable factors and store an empty list, because at the end this variable factor will store the all prime factors. Let's proceed ahead and define a while loop that says as long as n is greater than 1, it runs. This condition is defined here because we need to make sure that our original number must be greater than 1. Since we don't have any prime factors of any number less than smallest prime number, right? Therefore, we define this condition here. Now, inside this, we will define another while condition that says if n is totally divisible by the divisor, then we add this divisor in the list of factors. Meaning that if we find the proper divisor of the original number, then that divisor is the prime factor of the original number, and therefore we add that divisor in the list of prime factors. Now we reduce the value of the original number by dividing it with the divisor, and if in this case it happens that we don't find the proper divisor of the original number, then we increment the value of the divisor by 1 and finally we return the factors. Now to take input from the user, I will use here input function. Now I will use print function to display the prime factors, and as well as I will call here function and assign the argument to the parameter. Let's understand the code first. So first of all, I define a function prime factor and assign a parameter to it, that is n. Here n, it will take an integer as the input from the user. In the next step, I define a variable divisor that is the smallest prime number to find the prime factors. Later on, I define a variable factor that will store the all prime factors at the end. Here I define a while condition that says n must be greater than 1, meaning that we don't have any prime factors of the number that is less than smallest prime number, that is 2. Therefore, to make sure, we need to define a condition. And inside this, we define a condition that if we get the proper divisor of the number, then we add that divisor in the list of prime factors. And it is naturally that we get the proper divisor, meaning that the original number has been reduced. So to reduce that original number, we divided n by the divisor and store in the variable n, because we are updating here value of n. And this procedure will keep going on. And if in any iteration we don't find the proper divisor of the n, then we increment the value of the divisor by 1. And finally, when the remainder leaves 1, this while loop condition will become false, since 1 is not greater than 1, and we reach to the command return factors, where factor variable will store the all prime factors and here input function is defined to take the number from the user, and the print function is used along with the function, where print function is used to display the all prime factors of the number, and function is used here to call the function and assigning the variable number as an argument to the parameter n. So we can see clearly that we have got the prime factors of the number 40. So let's consider this example to understand in a better way. This example is taken from the QMath. Here we have number 40 and we start finding the prime factors of the 40 with the smallest prime number 2. So we know that the 2 is the proper divisor of number 40. So we get 20, then we get 10. Now we have here left with number 5. Since we know that 2 is not the proper divisor of the number 5, therefore we increment the value of the divisor, and we do this for 3 times. Means in each iteration we increment value by 1, as we have discussed here. And finally, when we get the proper divisor of the number 5, we divide this number with the proper divisor, that is 5, and remain with the remainder 1. So these numbers are the proper prime factors of the number 40. So we are left here with remainder 1. So since the n will be here 1 and 1 is not greater than 1, therefore while loop will be break and command will come over to here, and finally it will print the prime factors of the number 40. Let's proceed ahead with another example. So I will copy the code and paste down here below, since we have just need to make few changes. So first change that will take place here, I will use here if condition instead of while condition, and put this statement under the else statement, and this will go up inside the if condition. Now we need to make here one more condition, that is, but if the remainder is greater than 1, meaning that if the remainder is the prime number, then we add that remainder in the list of prime factors. Now let's understand the code. We have discussed it already. So I will start from here, that first we need to make sure that n must be greater than 1, right? After that, I define here if condition that says if we get the proper divisor of the n, then we add that divisor in the list of prime factors. And in the next step, we reduce the value of the n and update this in the variable n. And if in each iteration we don't find the proper divisor of the n, then we increment the value of the divisor by 1, as we have looked in this example already, right? Here 2 is not the proper divisor of 5, therefore we increment the value of the divisor by 3, 1 by 1 in each iteration, and finally when we get the proper divisor of 5, that is 5, we divide it and we leave with the remainder 1. So this is what happened till here. Now we discuss about this if condition that says if at the end in the position of remainder we get the prime number, then we add that prime number as the prime factors in the list of prime factors. And this happens because it is possible that if we don't divide this 5, we leave this divide as the remainder, then this 5, that is the remainder right now, we will add this 5 in the list of prime factors because 5 is the prime number, and we can see it is added here. And if we divide, as we can see this in this example, we divide this 5 by 5, and then this 5 is added in the list of prime factors. So it doesn't matter whether we divide this 5 or not, because if we don't divide, then still this 5 as a remainder, and since it is a prime number, it will be added in the list of prime factors, and we divide this 5, then this 5 as the divisor will be added in the list of prime factors. So this is what this says, that if the n, that is the remainder, is greater than 1 and the prime number, then we add that prime number in the list of prime factors, and finally we return the factors. So by using the input function, we take the number from the user, and by using the print function we display the prime factors, and inside this we call the function and assign the argument to the parameter n. Let's see here. 37, we have only two prime factors of the 37, that is 1 and the 37 itself, but 1 is not the prime number, since we are left here only with the one number, that is 37 itself. So this is the case where we are left with the remainder as the prime number, and therefore we add that prime number in the list of prime factors. I will use tree method to find the prime factors. Now I will use here code of the example number 1 that we have discussed already. There are just a little bit change we need to make, and this code will work as the tree method to find the prime factors. So instead of while condition, I will use here if condition, and this divisor increment command will come under the else condition. Now we need to define here one more if condition that says if the number is less than 2, then we don't have prime numbers. Meaning that if we have any number that is less than smallest prime number that we have discussed here in already, we discussed here that our number must be greater than 1, right? So in another word, it is written here that if the number is less than 2, then we don't have any prime factors of that number. Else we have prime factors. Understand the code first. We know we have discussed it already. By starting it from here, we have discussed that our number must be greater than 1 because we don't have any prime factors that is less than smallest prime number. Under the while condition, we discuss right now that if we have proper divisor of the n, Then we add that divisor in the list of prime factors and reduce the value of the divisor by dividing it with the divisor and update it in the variable n. Else, in each of any iteration we don't find the proper divisor of n, then we increment the value of the divisor by 1, and finally when we leave with the remainder 1, this while condition will become false since 1 is not greater than 1, and we finally reach to the command return factors where the variable factors will be storing the all prime factors. So to make this example clear, let's see this example here that is taken from the QMath. Here we have the original number 60, and this is the method where we find the prime factors using tree method. So we find prime factors by using smallest prime number 2. We know that the 2 is the proper divisor of 60, therefore we get 30, then we get 15. Here we are left where with number 15. So we know that 2 is not the proper divisor of 15. Therefore, we increment the value of the 2 by 1. Since 3 is the proper divisor of 15, therefore we just increment the value of the divisor only one time. And we get the proper divisor of the 15, that is 3, and we divide it with 15, so we leave with the remainder 5 here, and finally we get the proper prime factors of the original number 60. Notice that this 5 is the remainder here, right? We can divide this 5 with the 5 and leave with the remainder 1, but nothing will change because this 5 right now is the prime number and the remainder. So we have already discussed in the previous example that if the remainder is greater than 1, meaning that if the remainder is the prime number, then we add that remainder in the list of prime factors, right? So this is what concept is applied here. So this is the remainder, but still this is the prime factor of the 60. Therefore, we add this. And if we divide this 5 by divide 5 and leaving it with remainder 1, still then 5 will be added to the list of prime factors, right? So doesn't matter whether we divide or not. So let's try the example once. Let's see, we have got here prime factors of 60. Thank you so much for watching this video. This video ends here. Have a great day.